Hello, welcome to Mathematics class for Standard 7th, Chapter 13, Exponent and Powers, Part 4. Students, what you're going to learn from this video? You are going to learn the remaining questions solution of exercise 13.2. You will be learning how to solve the complex sums and bring it to the simplified form, to the simplest form. So, let's begin. So, let us start with exercise 13.2's question number 3. Here you have to say true or false. But only saying true or false is not enough, because you have to justify your answer. That means you have to show that how your true or false is correct. So, let us start. Here you have 10 with no power. If no power is there, we will always consider 1. Okay, now let us start solving. As you could see here, the bases are same. Multiplication sign. So powers will get added. That is 1 plus 11. And this side we have 100 to the power 11. Now 100 is there. Correct? It's 100. We can turn this 100 into 10 tens, that is 10 square. Okay. So, here you have 10 to the power 12 now. But here I am turning 100 into 10 square and then power 11. As you could see, 10 tens are here. 2 zeros are there. That means it is 10 square. And then this 100, this means the complete 100 has the power 11. So, this also will have the power 11 here. So, here it is 10 to the power 12 and here it is 10 to the power 2 11s are 22. Now just compare. This 10 is with power 12 and this 10 is with power 22. Both are equal? No, they are not equal. Okay, but this one is greater. So we are going to write it as false. Right? So, we have given our answer as false, but the justification is given here because the question is not actually justifying the equality. Okay? So, the question is having the answer as false. Now, let us move on to another true or false question number 3. After 1 I had given with 3, so 2 will be homework for you. Now let us justify this also. As you could see, this is in 6th form. First of all, we have to bring it in 2 and 3 bases form. Okay. So let us solve it. If you want to solve, that is another method. And if you want to compare it, then also it is a different method. Okay. So if I am going to write as this as 2 cube and 3 square, and here I am having 2 3s are 6. I am splitting 6 into the factor of 2 and 3 with the power 5. Now 2 to the power cube and 3 to the power square is actually, now this 5 is common for both because 6 has been factorized, right? So let us give the power 5 to both of them. Okay, now watch this. Here 2 is having the power cube, but here it is having 2 to the power 5. Here it is having 3 to the power 2, that is 3 square, but here it is 3 to the power 5. So both are equal? No, they are not equal. So again we have statement as false. I hope student you are understanding. Now let us move ahead. Now we are going to do question number 4 of exercise 13.2. Express each of the following as a product of prime factors only in exponential form. This we had also done such question in exercise 13.1, where we have to bring the answers only and only in the exponential forms. Okay, so let us begin. We have 108 and 192. We have to do the factorization of both so that we can bring the prime factors of both the numbers. Let us begin with 108 first. So it is an even number. So let us begin with the table of 2. So 2 5s are 10, 2 4s are 8, 2 2s are 4. So from 5 deduct 4, 1 left, so put that 1 here, so it will be considered as 14. So 2 7s are 14. Now it's an odd number. So let us go with the test of divisibility of 3, where we add both of them. That is 2 plus 7. The answer is 9. And 9 is divisible by 3. So the whole number 27 will also get divided by 3. So that is 3 9s are 27. 3 3s are 9 and 3 1s are 3. So as we get 1 in the factorization table, that is the end of factorization. So for the question that is 108, what we have got? We got 2 how many times? 2 times. So we will write 2 square, and 3 how many times? 3 times. So we will write 3 cube. Now let us do the factorization of 192. As the number is even, we will start with the table of 2. 2 9s are 18, 1 left. Now consider this 1 and 2 is 12. 2 6 are 12. 2 4s are 8. From 9 took 8, so 1 left. 16. 2 8s are 16. 2 2s are 4. 2 4s are 8. 2 1s are 2. 2 2s are 4. 2 6 are 12. 2 3s are 6. Now 3 no more divisible by 2. So let us take the table of 3. 3 1s are 3. As soon as we get 1, this is the end of factorization. Now we got 192s as a prime factors of 2 and 3. Now let us write down 2 how many times been taken here for division. 1, 2, 3, 4, 5, 6. So we have here 2 to the power 6. And we have 3 as only 1 time, so that is power 1. Now as all are in multiplication, so let's arrange the common bases together. That is, here I have 2 to the power 2, and now I am writing this base of 2 here with the power of it as 6. Now what is left here? 3 and 3. So let us write down these 3 together. Now, why I have made a pairing like this? So that when the bases are same, I can add the powers. That is 2 plus 6. Why I am adding? Because multiplication sign is there. And 3 is 3 plus 1. So here we have 2 to the power 6 plus 2 is 8. And 3 with the power 4. So as the question has asked, please bring the answers as a product of prime factors only in exponential form. So see, these are the prime factors with their exponents. So this is how we have brought it as asked to do, right? Now let us start with the next question, number 4, where the question is 768 and we have to bring it in an exponential form. Nothing else is there in the question. So let us do the factorization of 768. As you can see, the number is even. We will start with the table of 2. 2 3s are 6, 2 8s are 16, 2 4s are 8. Again the number has come as even. So let's continue with the table of 2. 2 1s are 2, 1 left, 2 9s are 18, and 2 4s are 2 2s are 4. Here we have 2. Now 2 9s are 18, carried 1, 2 6 are 12, 2 4s are 8, 1 left, 2 8s are 16, 2 2s are 4, 2 4s are 8, 2 1s are 2, 2 2s are 4, 2 6 are 12, 2 3s are 6, and 3 1s are 3. Here comes 1, and I had actually done all the prime divisions with the prime numbers of the number 768. So how many times 2 has come? Let us count. 1 2 3 4 5 6 7 8 times, and 3 1 times. So this is how 2 has come 8 times and 3 has come 1 time, and this is the exponential form of the question 768. Now let us move ahead. We are going to solve question number 5 of exercise 13.2, where certain questions with so many bases in division and multiplication form, we have to apply all the laws here, right? See, the product of the product, then multiplication, and then they are in numerator denominator form, that is they are in fraction form, so we have to carry out the law of division also, right? So let's begin. Now as you could see, this is a power of power, so let's multiply both the powers. We have 5 2s are 10, multiple 7 to the power 3. Now could you see this 8? This power, this base is not matching with this base 2. So let us bring this 8 in the power of 2. So let's do the factorization here. 2 4s are 8, 2 2s are 4, 2 1s are 2. So here comes, so what is 8? 8 is nothing but it is actually having how many times 2 in it? It is a multiple of 2 3 times. So 8 could be written as 2 to the power 3. So in the place of 8, write down 2 to the power 3. Now 8 is already having one more power, that is 3. So write down outside the bracket. Okay. Multiple 7, no power is there, that means 1. Okay, now solve it. That's 2 to the power 10, 7 to the power 3, that is 7 cube. This is 2, 3 3s are 9, so we will multiply and write the answer 9 here, and here it is 7 to the power 1. Now could you see that the bases have come same? They are in division form, so numerator's power 10 will subtract 9 from it because 9 is in the denominator. So numerator's powers are written first and then the denominators. Similarly 3 minus 1. So let us write down 2 to the power 10 minus 9 and 7 to the power 3 minus 1. So you have 10 minus 1 as power 1. And 7 minus 3, that is 7 to the power 2. Now here it is not written as bring it in an exponential form. It is written as simplify. Simplify, that means you have to bring the number in the simplest form. That is, you have to solve till end wherever it is possible. You have to go on solving. So here we can solve further as so your little sum is left, so I am solving it here. It is 2 to the power 1, that is 2, and 7 square, that is 7 is multiple how many times? 2 times. So 7 sevens are 49 and 49 twos are how many? You multiply 49 and 2. So 9 twos are 18, 1 carry, 2 fours are 8 and 1 carried is 9. So answer is 98. This is the simplest form. So when it is asked to bring in the exponential form, then you can leave it here. But if simplification is there, then you have to bring the answer till end. Okay students, now let us move on to the next question. That's number 3. Here the base 3, 5 is there. Here 10, we can bring it in the form of 2 5s are 10. 25 as 5 5s are, 6 as 2 3s are. So we can bring the bases 2, 3, 5 after expanding them. So let's expand them. That is 3 to the power 5. Here 10 is written in the form of 2 5s are 10, sorry, and to the power 5 here. Okay, and 25 is written as 5 multiplied by 5. Okay, 5 to the power 7, and 6 is written as 2 3s are 6, and as 6 is having 5 power outside, I am going to write 5 out. Now this is 3 to the power 5. Now we can distribute this 5 inside the bracket to 2 and 5 bases separately. 2 to the power 5 and 5 to the power 5. Now this is 5 square, right? Because it is 1 and 1. So 1 and 1 is nothing but 2. It's 5 square is 25, right? Upon 5 to the power 7. And here again we can distribute 2 power 5 with 3 power 5 again. Okay. Now see, all bases 2, 3 have come. So what we will be doing? Now let us do it. We will make a pair of them together. So let's bring this 3 and this 3 together, this 2 together, and these 5s together. So let's write down 3 5 upon 3 5. So I am writing it just to match the bases. 3 5 up with this 2 to the power 5, and these powers will get added because 5 and 5 are same. So 5 plus 2 will be 7. 5 to the power 7, right? Now I am writing 3 first because here 3 is there. So matching with 3, I am going to write this 3 in the denominators 3 here with 3 to the power 5. Then comes 2, that is 2 to the power 5, it is down, and 5 is having power 7. Okay, now dividing the page into half so that I can solve the rest of all sum here. Okay. Could you see this 3 5 and this 3 to the power 5? They are in the division form. So their powers will get subtracted. Now turn of 2 base same, and the powers will get subtracted. Now the turn of 5 having the power 7, but they are in division form. So 7 also will get subtracted in the power form, right? Now 5 minus 5 is 0. 5 minus 5 is 0. 7 minus 7 is 0. All the bases are different. See, 3 base, 2 base, 5 base, but they have the common power 0. Any base to the power 0 is always 1. So 3 to the power 0, 1. 2 to the power 0 is 1. 5 to the power 0 is 1. And 1 ones are 1, 1 ones are 1. Your final answer is 1. I hope student you have understood this well. Now let us move on to the next question. Students, I am solving the second question for you now. because it is having a letter T in it, so it will not be a homework for you. I am going to show it how the things are working here, and how when the letters are left we are going to keep the answers. Okay, so let us bring the questions in the simplest form. As you can see, here is also 25. 25 is actually 5 square. Okay, so I am writing 5 square for this 25. This is already 5 square written here, which is in the question, so let it be as it is. T is having power 8, and then in the denominator you have 10. 10 could be written as 2 5s are, right? So we will write 2 5s are 10, and the power outside is given 3 because 10 is having a power 3 and T is having the power 4. So now, as you can see, the bases are same. We are going to add the powers, that is 2 plus 2, right? And let the T with the power 8 will be written as it is, and inside the bracket this 3 will get distributed to both the different bases, that is 2 cube and 5 cube, and T is having 4 power. So let it write it down as it is. Now bring the answers of this 2 plus 2 as 4 and T to the power 8. Now we don't have any base with power 2, so let it be as it is, and 5 is having the power 3, right? And then T is having the power 4. Now the bases of same one are 5 and 5. They are in division form, so 5 minus 3. So where 4 minus 3. The power is greater. Where it is greater? In the numerator. So subtraction also will come up here in the numerator. We are not going to do it down. So I am writing this 5, 4 minus 3. Now from the denominator, this 5 went here because it is in the form of division, right? So minus 3, this 1 5 up 1 5 down was there, they are in the form of division, so minus 3 I have written up, so this 5 is now gone. In the similar manner, you could see T is having 1 8 as an exponent to this T, where it is in the numerator and this is in the denominator. So this 4 is smaller, so it will be subtracted from 8 as division is there. A 1 T up, 1 T down. So division has the law of subtracting the powers. So 8 minus 4. As 2 is having no base similar up, so it is remaining in the denominator as it is. Now 4 minus 3 is 1, so 5 is having with the sign 1. Then what is T? T is having power 8 minus 4, 4, and 2 is having nothing but cube. Now let us solve it and write it. We can remove the sign of multiplication so that 5t could be written. It is 5t to the power 4, so this 4 is only for t, not for 5. And when 2 is multiplied 3 times, that is 2 multiple 2 multiple 2. 2 2s are 4, 4 2s are 8, right? So in the place of 2 cube, we can write the answer 8, because simplification is there. We have to bring it in the simplest form. Numbers could be multiplied and we can go to till the answers, but the letters will be having the exponent forms only. So this is the final answer. Thank you students for watching this video. I hope you have understood all the questions very well. We are going to meet soon with another exercise. Till then, have a nice day ahead. Goodbye.